Good evening, everyone. Welcome to this channel named Geeks for Geek School. So, today in this lecture, we are going to develop again a very beautiful game, and the name of that game is Snake Game. This is the part 1 of Snake Game, right? And in this part, I will tell you how you can use Ursina along with Python for developing a 3D screen, and then how you can create a floor kind of thing on which you can define some sprites you can use in your game, right? And also we'll be learning how can we make this snake move on the floor with the help of direction keys, right? So that's what we are going to do in this first part. So let's dive into the platform and start defining the code for the various things we'll be having in the program in the game. So the first thing is from Ursina import asterisk. We need to import everything from the Ursina game engine, and then we require one more module, and the name of that module is random. So it is going to help us in generating random numbers, and that's the name of the function with the help of which we will be asking the game to generate for us some random numbers. Right now, what the random numbers are required for, how we'll be using those random numbers which the game will generate for us by the code which we will fire. So that's what we are going to talk about later on. Let me now define the basic structure of Ursina. So app is equals to Ursina, and then in order to run Ursina, we can simply use this name app, and then we can use this function run. So what this will do, it will create for us a display window. So this is Ursina's display window, and we can now define whatever we want to on this window. Let me know. Let me just close this window, and the first thing I would like to define on this display is this sky named image. Uh, Let me just show you the image. So I have downloaded it from the internet. I will be using this image as a background for my game, right? If you don't like this image, you can download any other image. It is totally your call which image you want to use as a background. But how to use it, how you can put it on the 3D environment of Ursina, that's what I would like to tell you now. So it's with name sky.jpg, right? It's a jpg image. So what we can do, there is a function named entity. If you don't know about this function, please do go check out my previous tutorials I've shooted on Ursina. Definitely you are going to get a very good understanding of Ursina then. So we can simply pass quadrilateral as a value for this model property. Let's keep a scale of 60 because I want to see the image covering the entire window. That's the reason I've defined the scale as 60 here. And then using this property texture, we can put the image on the as a background on our display window. So the name of the image is sky, and the extension is JPG, right? Okay, good to go. Let me just save this thing, and now if I will run the code, let me check if I'll get to see the image or not. Okay, so this is what is visible to us over here. Why the skies are not visible? It's because it may be because of the scale we have defined here. Let me change it to 40, and now if I will run this code, okay, it's not looking good. And if I'll change it to 20, so it's coming white, but we are not able to see the complete background. Only the white cloud, some white cloud which is there in this image is visible to us. I think this part is visible to us. Uh, we'll have to rotate the camera. We'll do it later on. Fine, we'll do it later on. Let me first define the code with which we can have a gray, what we call it, gray floor. So we can use this variable field size, and I would like to have a field of size 19, right? And then we can have another variable with name field, and let's use the same function entity because it's again a new entity that we want to create on the display window. So model, to this model you can pass quadrilateral, and what is the color you want to see, what color of field you want to see on the display. So you can pass the color like this. I want to see a gray color window, and then you can define a scale. So I would like to have a scale of 12 by 12, and then you want to position the field. So you can use this position attribute, and let's now divide, let's pass the values for this. So for X, I'm going to have field size by 12, and for Y also, I'm going to have field size by, sorry, not by 12, but by 2, right? It should be half of the total field size. And then we can pass 0.01 for the Z axis, right? And what else can we do? So we are done with putting this field over here. Let me now run this code and see whether we'll be able to get something on the display or not. So we are able to see a gray rectangle getting reflected over here. How shall we bring it in the center? So, we can position our camera in such a way that we can see this gray rectangle somewhere in the middle of the screen. Now, to do that, we can make use of the simple code camera dot position, right? And then, okay, and of course, field size, and by 2 minus 18 comma minus 18 we can put here. Then we can, let me just check whether I'll be able to now get to see the rectangle or not. No, the rectangle is still over there right on the top in the corner. I will have to rotate my camera along the x-axis. So for doing that, that's the attribute I can make use of, camera dot rotation x. Let's rotate it by 60 degree. I think we'll be able to get the required output. Now why the output is not visible to us? If I will comment it out, let's see what's gonna happen. Okay, no, the this field is not visible to us now. Why is it so? That's what I'll have to find out now. So field size is 19. This is perfectly fine. Field is this entity model, quadrilateral, color is color dot ray, scale is 12 by 12, position is field size. This is also perfectly fine. And then we have this. Okay, so we are done with rotating the camera also. Let me do one thing. Let me just call this thing right on the top over here. I think it will make some difference. No, still the window is visible to us, but neither the sky nor the gray color box or gray color field is visible to us. Let's make it 56. I think we'll be able to get the required output now. No. How about -5? Okay, so the image is visible to us now properly, and this rectangle is visible to us, but not the complete rectangle, right? I'll have to shift it a bit more. If I'll make it 30. Okay, so this is what I am getting right now. It's not fine at all. I'll have to change the scale to 60, I think. then it will be able to cover this entire window. Yes, it is perfectly fine. We'll have to shift the camera a bit more. Okay, so if I am doing 60, if I'm doing 40, so the camera is taking the corner part, and if I will reduce the number, okay, the camera is coming closer to the what we call it, the gray field. Now, why is it happening? This is what we'll have to find out. Minus 0.01. Let's make it 1.9. Now if I will run it, okay, so this is what is visible to me right now. Let me make it 60. It's not it's not giving me a perfect output. Why is it so? I'll have to check it. So I'm done with importing this Ursina over here. A random module I've imported. App is equal to Ursina. Entity is equals to model. Quad scale 60. Texture is equal to this. Field size, I think 19 is fine. Right, and then field is equals to entity model quadrilateral color dot gray. Scale is perfect, position is perfect. So why are we not getting the required output? Now this is an issue. We'll have to resolve it. Camera dot position, we have positioned it at this point. If I'll change it to 1.8, okay, no, it is not giving me the correct output. I'll have to reduce it to 20, I think. So I'm able to see this table, but I want to get the top view of this table, right? I think this can give us the top view, but we are not able to see it now. Why is it so? Why is this not giving us the correct output? Just a second, I have the code over here. Let me come down and just copy this thing from here on this Sublime text uh, file, and I'll have to remove all these things from here. Perfectly fine. App.run. Let's see what this will give us. So I'm sorry. Okay, so this is what we are getting, and it is perfectly fine. I think there was some issue earlier because of which we were not able to get the correct output. And I have used the same code here also, which I defined earlier, but no problem. So app is equal to Ursina, then this is how you can get this image in the background. Then field size is equal to 19. Field is this, so this is for getting the red color floor. If you want to change it to gray, you can simply make it gray by changing the value here from red to gray, and this is what now you'll get. So it's a gray floor we are getting right now. Fine, and it's totally your call what value you want to pass to this color attribute here. Then camera dot position, we have positioned it at this point, and we have rotated it by this angle so as to see the floor. Right, it's time for us to now define the code with the help of which we can see the food on the gray floor. So we can have a variable like this, apple, or if you want, you can have a variable of your own choice. It's totally your call. An entity parent, because we want to see it on the floor. So parent is going to be field, right? And then model is going to be, it should be a sphere kind of thing. Fine, then what color of food you would like to see? I would like to see a red color of food, so color dot red. We can put here, and then we can pass 0.05 to the scale as a value, at which position you want to see it getting reflected initially when you start the game. So point 1, comma, minus 0.03. So what it will do, it will bring the what we call it apple on the gray floor. Because I want to get the score also incremented after every collision which is going to happen in between the apple and the snake, which I haven't defined the code for yet. So we'll have to put a collider also. So I've defined a collider box for this apple. Now with the help of this collider box, we'll be able to check the collision thing also. Let me now enlarge the size of the screen so that the code can be more visible to you guys. And now if I will run the code, so this is what it will give us. So we are able to see a red color food getting reflected somewhere in the middle of this gray floor, right? Okay, this is the background, this is the floor, and that's our apple. It's time for us to define the snake's code. So for getting a rectangular snake, we can simply create a class with name player, right? So to your call with what name you want to create the class in which you would like to have all your functions stored. So I've defined it as player. So the first one is going to be, of course, init function, and then we can pass self as a parameter to this. Then we can have this super function, right? For inheritance, init, sorry, and then we can simply come down and let's initialize the parent as field because I want to see it getting reflected on the gray color floor, right? And then we can, for this model, pass cube. So rectangle kind of thing will be visible to us. Then self dot color, what, which color of cube you would like to see on the floor. So I would like to see a black color snake. Self dot scale, it's time for us to define a scale. So I would like to keep it 0.05, and at what position you would like to see it getting reflected initially. So I would like to see it at this point 0 comma 0 comma minus 0.03. Let me save the changes. Fine, I'm done with saving the changes, and now if I will run the code simply, I will not be able to. I'm getting this error. Why? Because there are two separators over here. Let me just remove one, change the, made the required changes, and it's in running mode right now. But I'm not able to see the snake. You know why? Because I haven't created any instant or object for this class. But before creating an object for this class, I would like to define some more variables I'll be using for this snake of mine. So collider is also one thing we need to define because in order to check the collision happening in between the snake and the apple. Then for keeping a check uh, on the x position of the snake, we can use this dx variable. I am initializing it as I was initializing it with 0 for now, and similarly for keeping a check on the position along the y-axis of the snake, we can use this dy variable, and let's initialize it with 0. How many apples snake has eaten? Or keeping a check on this in the count of the same, we can have this variable, we can use this variable eaten, and I have initialized it with this value 0. Right, now in order to see the black snake head on the display on the gray floor, we can create an instance or object of this player named class which we just defined the code for. over here. Let me save the changes, and now if I will run the code, let's see what's going to happen. So we are able to see this black color, snake getting reflected over here on this gray color window. Now, if I'm pressing the direction keys, I'm not able to move this snake. Now, how to control the movement of the snake? Let's define the code for the same. So for that also, we're going to have some functions over here. Def update, that's the function which gets called by the game every time a new frame gets created, right? So define update function, and I would like for every frame the value of this variable x should be different. And how can we make it different? We can call this time attribute, and then we can simply multiply it with self.dx. Right, same thing we can do for the for another variable, which is y. Here will have to change it to y. So I have created a link in between this y and the dy, right, which we'll be using for controlling, keeping a check on the y attribute of the position of the snake. And also I've created a link, in between the x and this dx variable. So dx is for, we'll be using it for keeping a check on the x attribute of the position of the snake. It's time for us to now define the code with which we can make the snake move along all the axes. So we can have a function with name input. Let's pass self and this key as parameter to this function. So if the key pressed is equals to right arrow, if the user will press the right arrow key, what should happen to the snake's dx position? And what should happen to the snake's dy position? So the x attribute should change by 0.3 and nothing should happen to y. Why is it so? Because if he has pressed right arrow, it means that the user want the snake to move in the right. So it will be because the user wanted to move along the horizontal axis. So that's the reason the vertical axis is not going to get affected. So that's the reason I have passed 0 to this dy and zero point 0.3 to this dx. If you want a faster movement, you can change this to a higher value. Let me now copy this code. Sorry, let me save the changes and run the code for you guys. Let's see whether we'll be able to make the snake, we'll be able to make the snake move or not. So I'm pressing the right direction key. I'm able to see it moving. See, it is moving. That is great. Now we can use the same code for moving the snake in the left direction. So if the left arrow key will be pressed, it should be minus zero point 0.3 because the value of x, if it will start decreasing, automatically the snake will start moving in the right, in the left direction, right, and the dy should not get affected. Same thing we can do for moving the snake in the upward direction. So if the upward arrow key is pressed, at that time what should happen? The snake should start moving upwards. So what we can do, we can simply make use of the same attributes here and we can pass these values to dx and dy. Then we can use the same concept for making the snake move downwards. So if the downward direction key will be pressed, so dx is going to be 0 and dy should become equal to minus 0.3. Let's save the changes, and now if I will run the code, let's see what's going to happen. So I'm able to now move the snake in all the direction, as you can see, right? So it's moving downwards, it's moving in the left side, I'm able to move it upwards, I'm able to move it in the right direction also. Okay, so the code is working perfectly fine. It's time for us to now define the code with the help of which we can check the collision happening in between this snake and the boundaries of the gray wall. So the moment it comes in contact with any of the four boundaries of this gray wall, I would like a message to get reflected in the center of the screen. and I would like my snake to go back to its initial position where it was earlier in the starting of the game. So for getting this thing, we can use this if control statement. So if the absolute value of self dot x, right, it will give us the integer part. So if it is greater than 0.47, or if the absolute value of self dot y is greater than 0.47. So we need to check both self dot x as well as self dot y, and I would like to print on my screen. So this is the function you need to keep in mind if you want to get something printed on the screen at any point of time. So print on the screen you crashed. That's what I would like to see getting reflected on my screen. And I would like my snake to go back to its initial position. So I would like the position to change to 0 comma 0. It should go back to where the origin of the window is. So 0 comma 0, and then sorry, it is for the text, not for the snake. It is for the text. So this text should get reflected at this point, right? And let's define the scale also. So I would like to have a scale of 2, and for what duration you would like to see the text getting reflected, I would like to see it getting reflected for at least 2 seconds. So after 2 seconds the text will go away automatically. Let me now save the changes and run the code and show you the output. So we are able to see the snake, the apple is visible to us. Let me just run this game. So I'm able to make this snake move along all the axes in all the directions it is moving. So moment it will come in contact with any of the four boundaries. So that's what it's getting reflected over here. But the snake is not stopping. It didn't came back to its initial position. What I want is if at any point of time it comes in contact with any of the four boundaries besides the message, I would like the user to see the snake uh, going stationary, and it should come back to its initial position. The user should see the snake somewhere over here, right, where he see the snake right in the beginning of the game. So for doing that, we can simply use 3 lines of code, and we can put those 3 lines over here. So self dot position will become equal to, I think it will be great if I'll pass 0 comma 0 here. Then we can make this self dot dx also equal to 0, because that's the variable which is controlling the movement of the player, controlling the movement of the snake along the x-axis. If it will be 0, so the snake will stop moving along the x-axis. Similarly, if you want to stop the snake moving along the y-axis, you can make it 0 too. Right now, if I will run the game, so this is what I am going to get. So the snake is stationary at present. We are not able to see it moving. The moment I will press the direction keys, it will start moving. We are able to see the snake moving along all the axes, and let's see what is going to happen if it will come in contact with any of these four walls of this gray floor. So a message is getting reflected, you crashed, and as you can see, the snake is now not moving. It has come to a stationary position, and it's the same point where it was getting reflected earlier in the beginning. So this is going to happen forever till the game is on. Moment it will come in contact with any of the four x's, it will go stationary and it will come back to its initial position. The user will be able to see it over here somewhere in the center. Fine. Now it's time for us to define the code with the help of which we can check the collision happening in between the snake and our apple food. How to do that? So it's very simple. We are going to use the same concept which we used in the previous game we developed using Ursina. So I need to come down and let's use this variable hit info. So that's the same variable, if you remember, which I used in the previous game for checking the collision in between the main player and the obstacles. Self dot intersects. So that's the function which help us in checking whether the player has collided with something or not. So if at any point of time the value of this becomes true. So what should happen to apple.x? I would like a random number to get generated and it should be assigned to apple.x. So with this, what will happen? The position of the apple will change. It will be assigned a random position after every collision along the x-axis. And if you want to do the same thing for the y attribute also, you can do it like this. Simple. Let's run the code and check out the output. So now if the snake will hit the boundaries, so this will happen. And if the snake will hit the food which is there in the center of this gray color floor, so this will happen. So you can see the apple is changing its position, and this is what you will get to see as an output. I hope you are liking this video. Please do not forget to like and share this video in your groups so as to make it reach to the maximum students possible. In case you have any doubts, any queries, feel free to put them down in the comment section so that I can see them and I can help you guys in resolving those queries of yours. Right, so this is what we are getting right now, and now if the snake will hit the boundaries, so again this will happen, but the position of this apple will not change. Right, if you want to change the position of the apple, if you want the position of the apple also to get affected, when the snake collides with the boundaries of this floor, so you can do that also. You can simply copy these two lines of code and you can put both of them down over here inside this if control statement. So now if you will run the game, so this is what you will get to see. So the moment the snake will collide with the boundary, so yeah, as you can see, the position of both the snake as well as this food changed. See, again the position of both the objects changed. So that's how you can, control this whole game. So this is all in this video. This was the first part which I just showed you. Now the second part I'm going to show tomorrow at the same time, which is 5:30 in the evening. So please be there if you want to learn more about this game. We'll be talking about something more tomorrow, right at 5:30 in the live online class, which I will take on this amazing channel, Geeks for Geeks School. So we'll be talking about how can we code, what is a code we can define for getting a tail created for this snake, which is right now traveling on this gray color floor. Besides, how can we make the size of the tail or the length of the tail increased after every collision. So that is what we are going to define the code for tomorrow, right? And besides that, we are going to learn how can we get a text kind of thing reflected on this Ursina's display, right? So that's what we will do tomorrow in the online live session, which I will take on this channel named Geeks for Geeks School. If you want to learn the basics of Python, you can check out the tutorials which are there on my channel, and it's with name Gaurav Kumar Jain. Right, just type it on in the search box of YouTube, and you will get to see my channel right on the top on YouTube. Just visit the channel, check out the videos in order to learn more about Python. You want to learn block-based coding, so you can find the tutorials on that also on my YouTube channel. Thank you very much all of you for joining me at this time in this tutorial. I hope you guys liked this one a lot. Do not forget to share this video in your groups so as to make it reach to the maximum students possible. Thank you very much. Have a great day ahead. Bye bye and take care, everyone.